All right, so thanks, Peter, for starting the recording, and good morning, everyone. Thank you all for joining us, and welcome back to the NL Seminar Series. Our guest speaker for today is Lara Martin. Lara Martin is a 2020 Computing Innovation Fellow and a postdoctoral researcher at the University of Pennsylvania, working with Dr. Chris Callison-Burch. In 2020, she earned her PhD in human-centered computing from the Georgia Institute of Technology, where she worked with Dr. Mark Riedl. She also has a Master's of Language Technologies from Carnegie Mellon University and the BS in Computer Science and Linguistics from Rutgers University. Dr. Martin's work resides in the field of human-centered artificial intelligence with the focus on natural language applications. They have worked in the areas of automated story generation, speech processing, and affective computing, publishing in top-tier conferences such as AAAI and IJCAI. Sorry. So they have also been featured in Wired and BBC Science Focus magazine. Today, they will be talking about how tabletop role-playing games such as Dungeons and Dragons can be used as motivation for how to improve conversational systems and understand how people communicate. Please join me in welcoming Lara, and I hope you enjoyed the talk.
Great, thank you so much. Thank you all for coming to my talk. So I have my lovely punny title, Dungeons and Discourse, using computational storytelling to look at natural language use. All right, so you're probably familiar with conversational systems like Siri or Alexa or Cortana, but there's something lacking in these systems, like that you can't just pick one up and have like a conversation with it. So what exactly is wrong with Alexa? So she is lacking a long-term memory, so that she can't continue on a conversation. She's lacking this storytelling or creativity aspect, so she becomes more repetitive and less engaging. And she also lacks like an emotional understanding, so she's lacking sympathy and compassion. And if we know all this, why isn't it solved yet? Well, it turns out that these are really hard problems in natural language processing, as I'm sure you're all aware of. So we know that there's basically an infinite number of sentences that someone could say, just because of recursion and all that lovely stuff. There's unexpected consequences to the actions that we take. So even if I say something and I think you might respond a certain way, you could surprise me and respond a different way. We live in a dynamic and continuous world. So the world isn't nicely discretized like computer scientists like to think. We also live in a distributed world. So what I think is happening might be different from what you think is happening. It might be different from what I think you think is happening. And we also get a sense of intrinsic reward from these discourses that we have with each other, like where we might enjoy talking about certain topics or just like being with other people. So you're probably all thinking like, oh yeah, these are also hard problems in Dungeons and Dragons. But you probably weren't, but if you're like me, I like to think that Dungeons and Dragons is like the next hard challenge for AI to solve. But if you're not familiar with D&D, it is a tabletop role-playing game with a dungeon master or DM and players who control characters. But it's also, if you look at it from like an AI perspective, it's planning and acting through dialogue and collaborating to tell a story. So why is storytelling important? Well, it's one of the most natural ways that we have of communicating. I could tell you a story about how I'm teaching my dog how to talk using buttons. And one day he got so excited about dinner that he ripped the dinner button off of the mat. And when I tell you that story, it tells you information about me. It tells you that I am interested in language. I am interested in my dog. But it also doesn't tell you information. It doesn't tell you what happens when you rip a button off of a mat, what happens when you press a button, like what a dog is. And this is the kind of information that I'm just assuming that you know due to your experiences in the real world. So if storytelling is so important, like what could we imagine this future, idealistic future world where computers could tell stories? What would it look like? So they'd be able to entertain us. I could say, Alexa, tell us a spooky story about the Jersey Devil. Plan with us. I could say, Bixby, what makes for a good party? Teach us. Siri, how do I bake cookies? Prepare us. Cortana, how do I ask this guy out? Or even support us. Hey, Google, I just broke up with my boyfriend. So teaching computers to tell stories is not a new field. This is called automated story generation, and people have been working on this for a while, at least since the 70s. So one of the earlier systems, like called Tailspin, would create stories like this. One day Joe was thirsty, Joe wanted not to be thirsty, Joe wanted to be near the water. And these stories are kind of dry, but they're planning for these characters to reach certain goals. Let's see, do we have a, okay. And people have still been working on it with these planning type systems. And the system called CIFellow has a lot more of a sophisticated plot going on. It actually has a plot, kind of. It's like there's a knight, and the knight goes through this adventure and defeats the sorcerer, and then like there's a prince and the king gives us gold and stuff. And so it's a lot more it's a lot more in depth, and we're improving since the 70s, thankfully. And so these two examples that I just gave you are examples of symbolic systems in storytelling, automated storytelling. And these systems include things like schemas, causality, and planning. And these are like the three things that I'm gonna kind of bring up throughout the talk. So say you have a story like this, like a chain of events. This is a very linear story about customers picking up drugs at a pharmacy. You can look at these individual nodes in this chain. These are schemas that hold specific information so that you can do like some kind of computation on them. You could also zoom in on these links and notice the connection between them. So in order to, once you leave, the pharmacist asks for prescription schema, then it is basically asking, okay, well, now do you have the prescription? Because you need the prescription in order to enter this customer produces prescription. And you can make longer chains. So in order for the pharmacist to deliver the drugs, the customer has to have produced the prescription. And you can also make branching stories. So maybe the customer does not produce the prescription, and in case the pharmacist has to call the doctor's office. And this branching leads to planning. So these stories are very coherent. They make sense. Like, okay, Joe was thirsty. He went to get to the water. He got to the water. We're good. But they require a lot of knowledge engineering to make. So they're like, people need to inject all of this common sense information in order for it to make these like reasoning steps. And then because of this, it is possibly lacking diversity and novelty. So there's only so many stories or story types that it could tell. So like, so this all leads to a limited domain. So like I can only tell a story about picking up drugs at the pharmacy with that last chain. So this was a very like closed world example. So you can only tell stories with what's there, versus what I like to call and other people like to call an open world story, which is basically the set of all possible events that can occur in a story is the same as the set of all possible thoughts a human can think of and express through language. So it's like anything is possible. And this is like the ideal of what we want in a storytelling system. So in other words, it's like you give a prompt to a system and it just tells you the rest of the story. And we've all tried this with neural networks. We throw in a bunch of stories into a neural network and it generalizes over this, and then we hopefully it generates a story. But it's putting a lot of pressure on this one element of the AI. It's basically just all neural network. And so what happened? Well, what had happened when we used like sequence-to-sequence networks? I trained on a model on a bunch of science fiction, or no, this is, sorry, movie plots. And then so I have a sentence: R2-D2 carrying some drinks on a tray, strapped to his back, passes Yoda, who uses his force powers to hog the drinks. That's like that's my input sentence. And what I expect, which is like the original next sentence of the story, is Obi-Wan and Anakin are drinking happily, when Chewbacca takes a Polaroid picture of Anakin and Obi-Wan. But what the network produced instead is, can this block gives him the advantage to personally run around with a large stick of cheese, which is just not relevant at all. But it gets the grammar right. And so there's something interesting here that I'm going to like tease apart in the next couple of slides. So to compare, symbolic systems create coherent stories but have a limited domain, versus neural systems, which create open world stories, but the coherence is terrible. But the ideal is to have like the best of both worlds. So in the rest of my talk, I'm going to go into my neurosymbolic story generation work, where I talk about events and plot progression and common sense reasoning. And then I'm going to talk a bit about some of my current and future work, where I'm working on like character modeling and inference. So part of the issue of what's happening here, sorry. So you're probably saying like, Lara, we don't use sequence-to-sequence networks anymore. So like, I want to show you that this is still an issue with GPT-2 and GPT-3. So if I put in a prompt like, the hungry dog licked her lips as she watched her owner eat, what I get out is "You've been a good girl," he told her. "I think you deserve a reward." Once she was done, she jumped back on the couch and waited patiently. Her owner took a piece of steak out of the fridge and gave it to her. "Thank you," he said. "I'm glad you're my dog." She wagged her tail and ate the steak. "If you're good, you can have a treat later," he said. "But for now, you have to sleep. I have a long day tomorrow." She nodded and lay down on the floor. Her owner got up, turned off the lights, and lay down on the bed. And at like first glance, again, it has really good grammar. So you would think like, this is an oral story. But when you start to think about the details, it has trouble remembering the story state. So it doesn't remember where, like whether or not the dog actually had a reward or not. And it lacks common sense reasoning. So it's making the dog nod in a very like anthropomorphized way. So we are still having these coherence issues, even in transformer models. So part of the reason why I believe that this is happening is because there's sparsity in the data. So when we see this sentence about R2D2, this sentence only occurs once in the entire data set. So it's because writers like to write unique sentences. And so the way that I kind of got around this was by separating the semantics from the syntax. And I did this so that there's more overlap in the data set, and then the neural network can pick up on more patterns. And I used an event representation to create this divide. So I extracted what I like to call the juicy bits of the sentence, the subject, the verb, the direct object, and a modifier. And so if I have a sentence, Yoda uses the force to take apart the platform, I get the event, Yoda used force, empty parameter. And then what I did is I took a step further and I generalized these events so that there was even more overlap in the data. So I did named entity recognition. So Yoda becomes person 0. I looked the verbs up in Verbnet, which is a tool that I use later on, you'll see in the talk. And I looked up the nouns in WordNet and took the word that's a couple levels higher in the hierarchy. So then now Yoda use force becomes person 0 fit power. Now that I have this event, like what do I do with it? Well, I created a whole system called Aster, automated storytelling with event representations. And the way it would work is you have your sentence, like John unwittingly unleashes an insidious pox. You eventify it. It becomes John unleashed pox, or person 0 disassemble a contagious disease. And then I can feed this into what was then a sequence-to-sequence model and get out the next event in the story. Male spatial configuration, empty parameter, adopt. And then I could feed this back into the network and it will just like continue to produce the rest of the story. And I saw that by doing this, I was able to like drastically improve perplexity. So the model was way less surprised when it saw these events because they were more common. And then, but now if I have these events, I need to like, people can't just read them. So I need to translate them back into like English. So I had another sequence-to-sequence model that translated these. And so I could take the event male spatial configuration, empty parameter adopt, and get the sentence male crumples and is about to be sheath. And so when I did this, again, the perplexity dropped, which is great. So because there's more, it sees more of the data, and it can learn the patterns better. And it also increased blue scores, and I use blue here because this is basically like a translation problem. So it's looking at it's saying that these it's more easily generating the and finding the exact like match for the generalized sentences. So then once you have this generalized sentence, I actually tried to create this like working and long-term memory that kept track of the tags. So once John is mentioned, he becomes person 0, and then person 0 is saved in a dictionary and kept for later. And then this could be used to fill in the slots of the sentence, and out I get this sentence: he crumples and is about to be husked, which is much better than running around with cheese. So in the next part, the next couple parts, I'm going to be focusing on this like event to event loop, because I think that there is a lot of interesting stuff that could be done there. But for now, to summarize, writers like to be unique when they write. This makes it hard for machine learning to see patterns. And so we created a schema to aid in the pattern matching, but then this created a giant system that still likes to ramble. And so next is to try to prevent rambling. So normally when well, actually I can pause here for a second if we have any questions.
So you have this kind of careful 4-part breakdown of sentences, right, in your system?
Yeah.
And presumably the event to event production is also generating 4-part things, is that correct?
Yeah.
Does that mean that the generalized sentences tend to have that careful structure then in this system so far? Like you're getting like present tense sentences that are like subject, verb, object.
No, the event to sentence part makes it into like a regular sentence.
It's a text, right? But still with a fairly simple structure, right?
Yeah. These were, so it actually, we tried to what we called like split and prune the sentences, so that like if possible we could only get one event out of a single sentence, but like that's also not a solved problem. So it's very hard to go from like an event to a sentence because it's like the more difficult direction. But in general, these were still pretty simple sentences.
What happens if you if I guess in the creation of training data, maybe when you hit like something that's just not covered by WordNet or somehow isn't able to be analyzed, is that you just throw it out and you just deal with whatever you end up getting, or do you do some kind of back off?
So, well, I don't think we had an issue with WordNet, but Verbnet doesn't have all the verbs, so we would just use the like lemmatized word, and not the category.
WordNet has all the nouns?
At least the ones that we used. I don't know. It probably didn't actually, but we probably did the same thing. Just like I just remember running into that way more with Verbnet at least. But yeah, if like running WordNet on like my science fiction data set is a lot less likely to get all the words,
right.
Like lightsaber and stuff. All right. So plot progression. So normally when you have a story, it's got this like lovely, like certain points that capture the reader's interest. So if you have a romance, say like the characters meet at the beginning, but then there's unrequited love, but then they begin to admire each other, but there's a terrible discovery, and then they have an understanding, and then eventually they get married. And so this is kind of like our ideal, but we can't even really get it to hit one of these plot points. So I tried to fix that. So again, zooming in on the event-to-event network, I used the reinforce algorithm to determine whether or not it was heading towards a particular goal. So say we want the characters to get married, so marry is our goal. And then depending on how it's doing, we backpropagate that and like fine tune the network. So this reward was a mixture of verb distance. So given this current verb, how far away is it from our goal verb? So the closer the distance, the higher the reward. And story verb frequency. So how often does this verb appear before the goal verb at any length in any, like across all the stories in our data set? And so if they appear frequently before the goal, then you get a higher reward. Then we multiplied these together. Oh, you have a question?
So how is verb distance to goal determined? What does it mean for a verb to be close to another verb?
It's number of sentences away. Oh, wait. Yeah, this one. It's the number of, yeah, so it's like if it's just like the next verb in the, if the goal verb is the next verb in the story, then it's like a distance of like 0.
From your training data. Like you look,
Yeah.
so if Mary is your goal, you look at places where there is Mary, and then whatever the word that came before, the verb that came before Mary, escaped was the verb that came before Mary, so it's got a distance of 1.
Yeah.
Cool.
Yep, and then we multiplied them together times a constant to get a reward. But then we ran into an issue where because reinforce doesn't keep track of state, the system just really liked to just like gather as much as reward as possible at the very beginning. So it was like characters meet, then they get married. It's just very short stories. And so the way we got around that was we clustered, we created verb clusters based on the rewards. And so then we could constrain, when it was training, we constrain the system to only sample from the next cluster. So like if it's in cluster 1 now, and then it's generating a new event, it has to only generate a verb from cluster 2. And this actually helped the system, like it achieved the goal like 94, 90, like 93% of the time. And it shortened the stories a little bit from just like letting the system go, but they weren't like 2-sentence stories. And actually, I think the most interesting result here is that the perplexity actually dropped. And I think that kind of says something about how by like calculating this, this reward, we were able to like learn more about the actual data set than just like cross entropy could alone. So I'm talking the system up a lot, but like, are the stories actually any good? So we also did a human participant study where we had 175 mechanical Turkers rate a series of statements, and it was this reinforced algorithm, so policy gradient DRL, compared to a like vanilla seek-to-seek, and also comparing to the testing set as like the gold standard. And we used a questionnaire from Purdy et al. That are like verified statements backed by psychology. And we also wanted to check whether or not the story follows a single plot. And we also wanted to see if we can capture some sense of genre. So we asked them if it reminds them of a soap opera. But yeah, the three most like important in terms of coherence are whether or not the events occur in a plausible order, whether the sentences make sense given the context, and if it follows a single plot. And we could see that our model did significantly better than the baseline in both plausible ordering and single plot, and it didn't like mess up or do significantly worse or better than the baseline in other situations. So it's like doing what we want it to do. It's being perceived as a single plot and has a more plausible ordering. So far, we created a schema so that these semantic events can be generated separately from syntax. And this created a more semantically accurate plot generation, but would still lose coherence over time because it would ramble without a cause. And we created a way to fine tune the event generator so it acted like a reinforcement learner, and then created artificial states through this reward clustering technique. And then this made for more consistent plot-driven generation. So it's pretty cool. But the stories actually aren't as causally coherent as you would like. So as an example, this is a story that we showed some of the participants, and the goal was hate/admire, which are in the same Verbnet category. And the story is, our sister died, Gregory executed during the visit. Gregory adopted the girl looked like her mom, she was appalled. Penelope detested the jungle gym. So it hit the goal, but it's like not exactly causally consistent, or it doesn't make sense why we're talking about a jungle gym suddenly at the end. So that brings me to my next bit about causal reasoning. Any questions about the plot progression stuff? All right, so remember I was talking about causal chains? Well, I wanted to integrate that into this neural generation. So the way I did that was by using Verbnet, which coincidentally, not so coincidentally, was already in these events. So this is Verbnet 101. So in Verbnet, you have a sentence. So Jen sent the book to Remy from Atlanta. You get roles such as, we know that Jen is the agent, the book is the theme, Remy is the destination, and Atlanta is the initial location. And then we also get a set of semantic predicates, which are they're like sub events in order within the single verb. So at the beginning of this verb class, like we have of this frame, we have the book has location Atlanta, and then at the end it's no longer in Atlanta and it's with Remy, and then there's some kind of motion in the middle. I also can get information called selectional restrictions, which can tell me what types of entities can be filled in these roles. So the agent has to be animate or an organization, the theme has to be concrete, And the initial location has to be a location. Then I did some fancy shuffling these bits around to turn them into preconditions and effects. So now in order for this event, the sentence to occur in the story, we have to have the preconditions of the book has to be in Atlanta, the Atlanta has to be location, the book has to be concrete, and Jen has to be animate or organization, and so on. And I also got rid of some of the middle bits because I'm more concerned about what effects that this gives us. And so I took this information and modeled a little story world. So again, using this event to event loop, I treat the event to event model as like a genre model of a way of like getting the domain that we want. And this would give me my events, which are the same like 4 tuple events as before. And then I would pass them into this world engine that we created using Verbnet, which extracts a story state. So like the state will hold information about entities in the story world, such as Remy has possession of the book and is animate. And that informs also like whether or not a proposed event is valid or not. And so it gives a set of pruned candidate events that are all valid. And then you could feed this into some event selector, which for these experiments, it is just like the top one, but like you could also do something fancy like a reinforcement learner. And then so to show you an example with this asterisk with the Verbnet stuff compared to just like Aster, so just the regular event to event model without any symbolic processing. So with the neurosymbolic asterisk system, what I thought was interesting is that you would get these stories that have entities that are then brought back. And so it's kind of being like consistent within itself by like, yeah, bringing back entities. Whereas like the neural system, once it mentions something, it would just completely forget about it and go on to the next entity. And I thought that this was pretty interesting. And I also tried it with a transformer. So the genre model is now fine-tuned GPT, and then since I don't have events anymore, I now need like a parser to make it fit into my Verbnet stuff, and then the rest of it is the same. And then this could also be like fit into the whole system with the slot filler, but it gets rid of like a whole loop because it doesn't have to translate it back into sentences. So an example with this was I could leave it up here for a while. I don't know if you want to read it or not, but I want to bring out the difference with the non-causal, so just like regular GPT-2, a fine-tuned GPT-2, is that with the non-causal system, it would like forget things and kind of even after people die and stuff, it's like none of the wounds are fatal, and then like it's talking about the it's like destroying the De Soto a couple of times, and it's just forgetting like the state of these people and their world. And so that kind of like low level understanding of the story world is tracked better in the neurosymbolic system. All right, so to recap all of the stuff that I talked about, storytelling systems are important. Hopefully I convinced you of that. I have separated out semantics and syntax, so that means that like language generation can be longer and can concentrate on meaning throughout. I've added a bit of controllability in, so we can have this ability to solve longer term plans. And then I created this hybrid system for reasoning and maintaining this external state. So now it has it's a system that is consistent and tells stories that are consistent. So now I'm going to talk a bit about like some of what I'm working on right now. And so first, like looking at all my stuff, I introduced it in this framing of D&D, but like you can, even with these like slight improvements in story generation, we're not even close to creating a dungeon master. And it's because there's just so much that goes into these like to be a dungeon master. There's so many parts that you might not even realize. So some of those things might include like humor. So you would want the system to be entertaining. It might build rapport, and humor can bring attention to details. You might want a speech component to it, so it might actually like speak to you, so it would create a deeper interaction and lets the agent appear more understanding. And then it also adds extra information like sarcasm that you can't just detect with text. You could also add meta planning on top of it, which is what a lot of people in the more planning community of story generation have worked on. So you can manage the expectations of the audience. You can reincorporate existing themes that have been mentioned previously in the story, along with character interactions. So a lot of this work that I've done mostly focuses on events and what is going on in this like abstract sense of the story, but what's happening with the characters. So part of why characters are important are like, so if you have in this example, it talks a bit about Darth Vader and Luke Skywalker, and I'm sorry that I'm completely spoiling the entire Star Wars series if you haven't seen it already, but there's this moment where Darth Vader is like, oh, I know who your father is, I am your father. And if you didn't know any of the context or their relationship or anything, it might be like Luke might be like, yay, I know who my dad is now, it's so great. But no, that's not his reaction. He does not take this news well. And so the way that I am modeling this is like, if I have these characters, I can like graph them out, and I can measure these relationships like in each direction of, so like Luke Skywalker is angry with Darth Vader, where Darth Vader is disappointed and angry in Luke Skywalker, and then you can calculate all the other relationships across the story as well. And you can then have this relationship information in addition to this historical context, and then this will inform a more accurate prediction of character reactions. And so I'm doing this with Comet and some other tools. And so I can kind of like take this same framework and substitute in the bits for what I'm trying to solve. And then the last bit I wanted to talk about very briefly, because it's more like a teaser, is that I've been working with a student, Brian Lee, at UPenn, and we looked at contextual common sense inference, where like looking at given a sentence in a story, how is it causally related to like other sentences in the story? And we noticed that there was a conflation of generation versus actually solving this common sense inference problem. So it's again putting too much work on a single neural network to solve all the problems. So yeah, we're presenting that at workshop at ACL, and if you're going, please check it out. So yeah, these are hard problems, and I've been like dipping my toes in to a bit of them. So like I've looked at the infinite number of sentences and unexpected consequences in my event work, and now I did the dynamic and continuous world and the distributed world with some reasoning stuff. And then I looked at a bit of like an intrinsic reward with plot progression. And there's still a lot of work that I'm working on and other people are working on in this space, and it's very cool. At least I think so. Here's some of my like other storytelling work if you're interested. And then I've also done work in like speech and interactivity in the past that I'm hoping to eventually bring back in my career. We'll see. All right, thank you. Any questions?
Thank you so much, Lara, for the talk. That was really great. And now I will open the floor to questions from the audience. So please, if you have any question, don't hesitate to ask them either directly or post them in the chat.
Hi, Laura. I really enjoyed your talk. My question is, have you thought at all about how to constrain like an AI DM to respond appropriately to dice rolls? So like, you know, if it gives me a persuasion check and I roll a natural 1 on that persuasion check, it needs to come up with a next sentence indicating that I failed.
Right. I haven't thought of that particular example, like how much the what's the word? The influence of the dice on the dialogue. But I'm actually working with I taught a class on interactive fiction and text generation with Chris this past semester, and there's a group that I'm trying to help get their work published, and it involves Avre, which is a basically like a schema for DMing on Discord. And so yeah, it kind of like involves this more like structured information in with the text generation. So it's kind of related to what you're saying, but not quite on that same level. Yeah. But that would be a cool thing to look at. Thanks.
Thank you.
I see Jay Bukhara raised his hand, so go ahead.
Sure. I had a question about the line between static and dynamic. So at the beginning, you said, oh, we're going to use Verbnet, we're going to have all these events, but the events fail to capture, I guess, the kind of innate properties. And particularly if you think about something like D&D, there are things that are kind of more or less static, right? The stats that you have, like charisma, might move very slowly, whereas what you're wearing might change from, whatever, day to day. And so, there are those sorts of things. But if you think more broadly, there are parts that are not really well represented as events, and there are parts that are well represented events. But when we're trying to generate stories, we kind of have to call upon both of these sources. Have you thought about that interface and how to, really blend those things without making it feel artificial?
So if I understand your question correctly, you're saying that there's some things, there are events that happen on different scales, and that like how does that affect, I guess, the generation? Or
not exactly, right? So that's true. There are events that occur on different scales, but there are things that are just purely, that aren't well represented as events, right? You showed some of the classic work from storytelling. It was event, right? But
right.
If I know the car is blue, the car is blue. We don't need to have like
Right,
the event if the car was manufactured and then the robot painted the car blue and now the car is blue. That's not the way we kind of view it, right? We don't.
There's like facts about the world, and then events that like move the world forward. And so
and you could kind of view as the slow moving events like charisma as potentially static, right? Because, at least in people, right, maybe their personalities change so slowly, they're basically fixed. Whereas, in a D&D campaign, maybe your stats change a little more, but, you're still going to be an elf or whatever, right? Those things are not going to change.
Yeah, I think that's kind of what you could use the state for, as this way of like keeping this memory of this story as it goes along. But yeah, I am using it for like the more faster changes. But yeah, I think that I'm not sure how that would affect the generation itself.
Well,
I think it would just be like,
right?
There's different ways of representing this information. Yeah.
Well, maybe you could just clarify this, right? So in your model, it seemed very focused on these Verbnet-based kind of frames. And it didn't seem there was an obvious place you'd interject kind of non-frame or, non-event knowledge.
Yeah.
Do you have an obvious place that would go in, or a way to use that, or did I?
That's what I was kind of saying, like, I could use this. So you can kind of store that as part of the story state. So the way I'm treating the story state is it doesn't really delete information unless it's like overwritten. So you can kind of keep track of those really slow moving or like identity characteristics in there. But the way I set up the system, the state doesn't directly inform the generation. It just kind of like helps it. So like if you so I guess I could have more like information about like this person is shy. So if they're shy, then how does that make this next event possible? Or like would they like stand on the table screaming? Probably not. And so that would be like proved out. And so I could see stuff like that still like fitting in here. It would just be a question of where would that information come from?
And some of them might be the modifiers, right? Like, X shyly gazes at, Y, and then you kind of have a sense that there's like a shyness. That fits well into, I think, the way you describe the events, but I think, kind of extrapolating that to a character. Anyway, thank you for your answer.
Yeah, thank you.
Any more questions from the
Snoring
audience?
dog under me.
Hi, Laura.
Hi. Oh, hi.
Thank you so much for the talk. It's great, as usual. I just had a question about, have you worked with different genres with regard to this work? And I wondered in general if there are different challenges associated with different genres.
Actually, that is a very relevant question right now, because I started with the movie plots where I kind of I did topic modeling, and I kind of found like a romance genre, and then I wanted some like longer, more detailed summaries, and so I scraped a corpus of science fiction, like long-running TV shows, which I was like, oh, this is such a great corpus I made, but now I realize it's not that useful because the stories are too long, and also it's like these are just really hard entities for people to understand, and even if they do understand science fiction, if I'm mixing like Spock and Doctor Who are like doing things together, people are going to get confused, and I think I'm running into that a bit with some of my recent experiments. So I'm kind of like scaling back a bit, being a little less ambitious, and trying. I found there's a data set on looking at like common sense Q&A for stories that I'm gonna try out next. But if you're interested in data sets, actually, I have a resources page that was on my class website that I'm going to soon be putting on my personal website because I just found it so useful. So if you want to know about like just different resources, you should check that out when I put it on. But to answer your question, yes, it makes a difference, I think. Yeah.
Cool. Yeah, we can talk more about this at ACL then. Thanks.
Did you ever look into soap opera genre data by any chance?
No, like the original like, was it Universe that used that soap opera data?
I don't know. We were poking around just in seeing what had been collected and what could be used to try to like identify characters and things, and we were having a hard time doing much with it, but there's tons and tons of the data available, right? Like, I mean, it's less so now, but for years, right? Like, you'd have these like real quick scripts, and they're very stereotypy, and so we were thinking that we could get like, you know, the cad and the like innocent and the, you know, the prankster and the villain, and try to model character that way. But it ended up being, well, it probably still could, we just didn't.
Yeah, it's hard to find the right data set for what you're trying to do, because these systems are just like, we're not quite ready enough to just throw anything into it and have it understand. But yeah, I mean, if anyone has any cool data, I would love to see it.
All right, so I think we are a little bit over time, and if no one has any more questions, then I'll just thank everyone for coming to this seminar, and thank you, Lara, for the great talk. And I will have some more questions to ask you during our one-to-one meetings, and looking also forward to seeing you in our group meeting. Yeah, can you, Peter, stop the recording?